today's section is section 12.7, Explore Similar Solids. It is our very last section of geometry for this school year. Alright, two solids are similar if, big if, all dimensions are the same ratio. So that means the heights need to be similar, the bases need to be similar, the lengths need to be similar, the radius, the two radii need to be similar. Everything needs to be in the same proportion. So we have this cylinder here with a radius of 3 and a height of 5. We're trying to determine, are these two cylinders, either one, neither, or both, similar? To do this, first we're going to compare the radius of this one over the radius of the original. Is that equal to, are they equal? So is the ratio of the radii equal to the ratio of the heights? And we get this one equals 3, this one equals 2. No, they are not similar. Over here, we have 9 over 3. Is that equal to 15 over 5? Again, the other way to check these is to cross multiply. And we get 45. 9 by 5 is 45. 45 equals 45. Yes, these are similar. Alright. Two similar solids have the ratio of sides A to B. We talked about this before. And we know that the ratio of perimeters then is equal to the ratio of sides. So it's A to B as well. In the last unit we talked about, or the last chapter, in chapter 11, we talked about ratios of areas. And that was A squared to B squared. And being the smart people we are, we can figure out then that the ratio of volumes, third dimension, is going to be A cubed to B cubed. The biggest thing, as we saw in chapter 11, is you have to convert from one to the other in order to use the proportion correctly. So we have two similar beach balls have a scale factor of 7 to 6. Again, this is A to B. Find the surface area and volume of the smaller ball. So let's do surface area first. So surface area. We know that we have 7 over 6, that's A to B. We're going to square them. So we have A squared over B squared is equal to the surface area. Now, the question is 249.55 the larger or the smaller? Well, we're trying to find the smaller, so that means we know that 249.55 is on the larger ball, which will be corresponding with 7. And then we will cross multiply to solve. We know that 7 squared is 49, and 6 squared is 36. We're now going to cross multiply these. And solve for the surface area. One thing to remember is we're finding the smaller ball. If your surface area here is larger than 249.55, you did something incorrectly because you need to find a smaller value. Alright, next we are going to do the volume. Same concept. We're going to set up the volume as 7 over 6, except this time we are going to cube them because we are doing volumes. And the volume we are given here is 371.61. And now, same thing, we are going to cross multiply. So we have 80,267.76 equals 343V. And thus V is approximately the volume, 234.02 inches cubed. And again, our volume is smaller than 371.61, So that is a good sign. All right. Next, we have two cones are similar. Cone A has a volume of 125 meters cubed, and cone B has a volume of 512 meters cubed. Find the ratio of the radii of the cone. So we know that A cubed to B cubed is 125 to 512. And we are trying to convert this to A to B. How do you do this? Well, the opposite of a square is a square root, so the opposite of a cube is a cube root. So we are going to take the cube root of everything, and the cube root of 125 is 5, and the cube root of 512 is 8. And when doing this on your calculator, the button you are looking for looks like that. If you are using the TI-83 or TI-84, it is under the math option. If you are using a scientific calculator, you're going to have to push in the number 3 and then use the button that says X root on it. So you're putting in 3 for X, so you're doing 3X root. And again, that's for most scientific calculators. Some of them have a cube root button. If you don't understand on your calculator, by all means, make sure you ask me during class time, and we will look at your calculator and figure it out. All right, last one. A garden store sells gravel in boxes that are cubes. The edge of the smaller cube, which sells for $40, is 3/4 of the edge of the larger cube, which sells for $99.50. Which box is a better buy? Whenever you're doing these types of problems, basically what you're going to do is look at price per unit. To do the price per unit, you're going to take the volume, or you're going to take the dollars, the price, and then divide it by the volume, and we'll get the price per unit of volume. Just like in a grocery store, if you're trying to figure out which cereal is a better buy, you take the price divided by the number of ounces. Same idea we are doing here. So we're going to draw ourselves 2 cubes. Okay, so we have our 2 cubes. The larger one, we don't know what it is, we're going to call it X. And we'll label this one larger. And then we have a smaller cube. And this is 3/4 X. Now, personally, I do not want to work with these fractions. I don't like working with fractions if I don't have to. So what can I multiply with 3/4 by to get rid of it? Well, I can multiply by 4. So that's what I'm going to do. I'm going to multiply everything by 4 and get this one is 3 and this one is 4 units long, whatever our unit happens to be. So I'm just going to say it's 4x or 4 and 3, assuming the most basic option because they are similar from here. So our ratio of sides is 4 to 3. So our volume of our larger one is going to be 4 cubed, which is 64. The volume of the smaller one is going to equal 3 cubed, which is 27. And then we're just kind of saying these are units. So for figuring out the price, the large one is going to be 99.50 divided by 64 cubic units. And we get it's $1.55 per unit. And again, we're working with money, so we're rounding off to the nearest cent. For the small one, we have that it is $40 divided by, and there's 27 cubic units, which this works out to be $1.48 per unit. So which box is a better buy? The small one. So small box is a better buy. You save 7 cents per unit of volume, whether it's cubic inches or meters or whatever it happens to be. If these were multiples, maybe the smaller one was 6 and the larger one was 8 inches on the side. It doesn't matter. We figured out per the basic unit what would this work out to be.